Okay, so in this video I will be talking about the acid properties of transaction. Okay, so this is a very important thing, acid properties, that are mainly related to transaction chapter in DBMS. Okay, is it visible? Tell me first. Yep, it is visible. Okay, so what are the four acid properties that are involved in transaction? So the four acid properties that are involved in transaction are: A stands for atomicity. Okay, A stands for atomicity. Then next is C. C stands for consistency. Okay, what does I stand for? I stands for isolation. And what does D stands for? D stands for durability. So it's a very important interview question that is asked multiple number of times. Okay, when students give the interview. Okay, so these are the four properties, and basically the interviewer expects you to explain all these four properties. So what is the first property? It is atomicity. It means either a transaction will be executed, either a transaction will execute completely or it will not start at all. There is nothing in between. Okay, it follows the all or nothing rule. All or nothing rule. That means either it will complete fully or it will not start at all. So I will write like this: either full completion, either fully complete. Let me see whether this part is visible or not. Either fully complete or don't start. Okay, so this is the property which is ensured by the transaction manager, which is that if a transaction has started, then it will be completed fully or it will not start at all. Okay, there is nothing in between. Okay, so this is the atomicity. Now what is consistency? What is consistency? Consistency means that the state of the database should be consistent after the transaction has taken place. Okay, that means all the integrity constants are maintained. All the integrity constraints are maintained. All the integrity constants are maintained. What are the integrity constants? The one is check constant, with this is maintained or not, that will check. Next, there is one more constant which is not null constant. The transaction manager will also check whether this is maintained or not. There is one more which is primary key constant, foreign key constant. So the transaction manager will check all those constants that are applied to the particular columns. Are those constants maintained or not after completion of a transaction? The next property is isolation. What is isolation property? Every transaction should think that that transaction is running alone in the system. No other transaction is running along with it. Okay, but in reality what is happening? Multiple transactions are taking place simultaneously. Okay, let's say this is first transaction T1. Okay, this is second transaction T2. This is third transaction T3. So every transaction, all these transactions are running simultaneously. All these transactions are running simultaneously, but every transaction should think that he is running alone. Okay, this transaction should think that he is only running alone in the system. This transaction should also think that it is running alone in the system. This transaction should also think that it is running alone in the system. No other transaction is running parallelly. So this property is also ensured by the transaction manager. This is also known as isolation property. Now what is the durability property? Okay, durability property. Now there is one question. Can you tell me when are the changes made by the transaction visible? For example, this transaction is let's say increasing the value of variable r by 50. Now the value of r is currently 100. Okay. Now what it is doing? It is basically increasing the value of r by 50. Now can you tell me when will this change? Obviously the value of r will be now 150. After it is incremented by 50, it will be 150. There is no doubt in that. But the main question is, when will you get to see the final value of r, which is 150? When this value is written in the memory, when the value is written back to the secondary memory, then only you can see the value of r as 150. Before that, you won't be seeing the value of r as 150. Okay, so that's the very important thing. Next is durability. What does this durability property ensure? This durability property ensures that all the changes made by the transactions are successfully written in the disk. Okay, it is successfully written in the disk. So this is the property. This ensures all the changes made by transaction are successfully written to the disk. What does this mean? That for example this transaction, it is basically incrementing the value of r. Here there is one more transaction which is basically decrementing the value of r by 10, and there is one more transaction which is basically incrementing the value of r by 70. Now if after doing this operation, the final value, if it is not saved to the main memory, if the value or if the modification which is done by this transaction or this transaction or this transaction, if these are not saved in the memory, then will I be able to see the final value? Will no, obviously no, because if these operations, the value which are done made by these operations, if they are not saved in the memory, then these transactions are useless, right? So basically what is happening in, if I write in assembly code, it's basically move the value of r in a register named r0. Now next what I am doing, I am incrementing the value of r0 by 50. Okay, right? Then what I am doing, I am again pushing the value of r0 into r. So I am just again doing move, pushing the value of r0 back into r, right? So what happens, let's assume that at this stage the database crashes. Okay, when this instruction has been executed, the database crashes. So obviously the final value won't be moved in the memory. The final value won't be moved in the memory, then this transaction is useless. Right, this transaction is useless. Why it is useless? Because the final value is not changed, because before changing the database crashed, so there is no change in the final value. So that's why I need to first of all successfully save it in the memory. The changes that I made inside the transaction should be saved inside the memory. If it is not saved inside the memory, then this transaction is useless because it's unable to change the value. Okay, if you are able to change the value, you should store the changed value in the memory. So this is the fourth property, which is durability. So this is a very important interview question that is asked, acid properties of transaction. Now there is one more thing. What is transaction? If somebody asks you, transaction is basically the smallest logical unit of work. Smallest logical unit of work. The smallest logical unit of work is known as transaction. Okay, fine.